So today we're going to be talking about proportionality with triangles again, just a little bit more in depth. So the first couple things we're going to talk about are some theorems. So what this is saying is basically if we have two overlapping triangles, which we do have right here, if these two lines are parallel, then we can set up a proportion that says that this length, so TR, divided by TQ has to be equal to UR divided by US, which is what this is saying down here. Then the next theorem is the converse of that. So if I said that backwards, it would still be true. So if I knew that these were proportional, so TR divided by TQ is equal to UR divided by US, then that would tell me that these have to be parallel. So we're going to be using these things for most of the notes today. So in example 1, in the diagram, QS and UT are parallel, so that's what that little symbol means. So these two lines are parallel. Again, we see the arrow, that means parallel. And then they give us some lengths of the sides here. So RS is 4, ST is 6, QU is 9. What is the length of RQ? So since these two are parallel, I know that I can set up a proportion that says 4 divided by 6 is equal to QR, I'm just going to put X here. So QR or X divided by 9. So anytime we have a fraction equal to a fraction, we can cross multiply. So if you wanted to reduce 4 over 6 to 2/3, you can, since 2 goes into both of those. You don't have to, but it'll make the numbers a little nicer when we multiply. So now we can cross multiply. So 9 times 2 is going to be 18. 3 times x is 3x. Divide both sides by 3. I get x equals 6. So this side should be 6. If we have 3 parallel lines or more, and they're being hit by these transversals here, then all those segments that are being created or intercepted are proportional. So like if this was A, this was B, this segment was C, this segment was D. So I'm talking about these little things. Those segments are all proportional as long as these lines are parallel, which it says they are. So we could write a proportion like this. We could also write it in other ways. So BA divided by DC, or B divided by A equals D divided by C. We could also say that A divided by C equals B divided by D. So there's many ways that we could set these up, but the main thing is we need to know that these are proportional. So another theorem that we're going to talk about is if a ray bisects an angle. So hopefully you remember what it means to bisect. So this is bisecting this angle right here. So bisect man is coming down to separate this angle into two congruent angles. So those two angles would be congruent. So if that's an angle bisector, then we can write a proportion that looks like this. So AD divided by DB is going to be equal to AC divided by BC. So these two sides divided by each other are going to be equal to these two sides divided by each other. So we're going to do some examples like that at the end of the notes. But before we do that, we're going to do the parallel lines again. So find the length of YZ. So YZ is right here. I'm just going to call this X. So since these two are parallel, then I know that 35 divided by 44 has to be equal to X divided by 36. So I have two fractions equal to each other. So 44X has to equal 35 times 36. So I don't happen to know that off the top of my head. So let me use my calculator real quick. So 1260. And divide both sides by 44. So x is equal to 28.64. So example 3. Find the length of AB. So it doesn't really tell us necessarily, but I can tell that these are all parallel lines because we have one line going through all of them, and it creates a 90-degree angle. So that means that all three of these lines are parallel. So if all those lines are parallel, then I know that this, let me erase that line, and this are proportional, and then this and this are proportional, so I'm going to call this x. So we could say that 16 divided by 15 is equal to x divided by 18. So I'm going to cross multiply, so 5x. 16 times 18 is 288. Divide both sides by 5. And I get x is equal to 57.6. Oh, wait a minute. I did 5 instead of 15. So this number should have been 15. So 16 divided by 15, my fault, equals x divided by 18. So it should be 15x equals 288. So the answer should be 19.2. Sorry about that. But same idea. Doing the same thing, I just wrote the wrong number down. All right, for number 4. So I have an angle of the triangle being cut right there. This CD is 4, DB is 4. So that means that this line is going directly in the middle of this segment and also directly in the middle of this angle, since this is 90 degrees. So that means I can set up a proportion. So 4 divided by 4, and let's call this side x, has to be equal to 4 root 2 divided by x. So when you have a proportion, there's a little trick you can use anytime you have the same number on the top and bottom over here. If these two numbers are the same, these two numbers would have to be the same. So I don't even have to do any real math here. I already know that x is going to equal 4 root 2. Because if I reduce 4 over 4, that's 1. So what number would x have to be to make this side 1? Or if you wanted to, you could cross multiply and you get the same thing. But this should be your answer. And then in our last example, so we got an angle bisector here because these two angles are congruent. So anytime we have an angle bisector, we can use that little theorem. So this side, QR, divided by RS, is be equal to QP divided by PS. However, I do not know what QR is. So this one's a little tricky because we don't know what QR is. We know the whole length from Q to S is 15. And the length from R to S is X. So whatever X is, if I take that away from the 15, that will give me QR. So QR is actually equal to 15 take away, or 15 minus X. So my proportion would look like this. So I'll just write the letters first. So QR divided by RS is equal to QP divided by PS. So QR was 15 minus X. RS is just X. QP is 7. And PS is 13. So now I have two fractions equal to each other, so I can cross multiply. So 7x, that one's easy. This one's a little tricky. So I'm going to have 13 times 15 minus x. Oops. So I know you're running out of room on your paper. So I'd have to distribute this 13. So 13 times 15 is 195. 13 times negative x, negative 13x. So add 13x to both sides. And we get 20x is equal to 195 divided by 20. And x will equal 9.75. And that's all we had to do for that one.